In this tutorial we're going to create a digital clock. We have a mode button where you can set if you want to change the hours, the minutes and the seconds, and as you can see I change it with the set button, and if we wait for 5 seconds and do nothing, the clock will resume its normal operation. I've split this tutorial in 2 parts. We start with a very easy clock where the green button adjusts the hours and the blue button adjusts the minutes. In the second, more advanced part, we're going to create the menu you just saw. Also on top of this clock there's a tiny animation going on, and I also show you how to create it. In the description of this video you find a chapter list so you can jump to the chapter of your preference. However, I advise you to follow the complete tutorial so you can learn from my mistake and build this clock step by step. For this tutorial you'll need several components: an Arduino, a breadboard, an OLED display, 2 push buttons and 9 jumper wires male-to-male. In the description of this video you find links to web shops selling these components. Every project starts with a plan, and I often receive questions like, how can I do this project? I don't know where to start. I want to build this and that and I know what I want, but I don't know how to split it up and create this project in my Arduino. So therefore I have a small presentation to show you how I created this clock. If you don't like this, then you can in the description find all the chapters with the timestamps and you can directly skip to building the circuit. However, I advise you to watch this tiny presentation because you can learn how to structure your project. Our clock's main function is to display time. We want to display hours, minutes and maybe seconds. But we also need to adjust the time. So we want to adjust the hours, minutes and even seconds. So how can we do this? We can use a single button, and this button increases a minute every time it's being pressed. But there's a tiny problem with this. Imagine the clock is just 1 minute behind. Then you have to press once and you're done. But what if it's running 1 minute too fast? Then you have to press it 720 times if it's a 12-hour clock, and even 1440 times if it is a 24-hour clock. So that's not very useful. So we can add another button. So we have 2 buttons, an hours button which changes the hours and a minute button which changes the minutes. We might even have to add a 3rd button because we also like to reset the seconds. There is no use to setting the seconds to a certain position like 39. So you want to reset it to 0 the moment the seconds need to hit 0. After you've thought about these solutions, then you have to think in components. So we like to display the time. Therefore we need a display. And we need 2 buttons, one for the hours and one for the minutes, and maybe a 3rd one if you want to reset the seconds. Then you have to think about how this could look when you're designing your clock. So this might be a clock. It shows the time. We have our hours button and our minutes button. And on the top you see 2 bars, and that's an animation, and that's what we're going to make. I've split this up in 5 steps. First we're going to build a clock with delay. Then we're going to build a clock using MILLIS. Then we're going to add an animation. Then we're going to add a debounce to the buttons, and I'll explain in that chapter what that means. And last we're going to add interrupts to the buttons. In the second part of this tutorial we're going to look into the clock as you just saw in the demonstration. Our first step is to add the OLED display to the center of our breadboard. Make sure there is enough space to add 2 buttons later. Also keep in mind during this tutorial that your pin layout of the OLED display might differ. For example, the serial data pin and the serial clock pin might be on a different position. That doesn't matter for your clock, but you have to keep in mind to use the correct pins when you're connecting these to your Arduino. Our next step is to add two buttons. Make sure that they overlap this tiny gap in the middle of your breadboard. We're now going to make our ground connections. All pins in this blue line are connected with each other. So we're going to connect the right pin of the green and the blue button to this rail via this wire and the other black wire. Our display has a GND connection, which is also connected to the same horizontal rail on our breadboard. We're now going to connect the wires to our Arduino. The first wire is the ground, which goes from here from the minus rail to the ground on our Arduino. The red wire goes to the 5V of the Arduino. It's connected to the VCC of our display. The yellow wire is the serial clock, which goes to analog 5 on the Arduino. And the serial data, which goes to analog 4 on the Arduino. The last step is to connect the blue button via the blue wire to pin number 2. And the green button via the white wire to pin number 3 on the Arduino. Now that we've finished our circuit, we can now have a look at the code. Actually, very simple. If we look at the libraries, we're only using one. That's the U8G2 library. So I'm going to my tools and say manage libraries. And then we're going to search for U8G2. And then you see here U8G2 by Oliver. I already have installed this library, but you can install it if you haven't already. So then we continue. We have 3 different variables. Well, the maximum number of hours is 24, actually 23, 0 to 24, so 24 values. So a byte is sufficient to store these. The same goes for minutes and the seconds. Then we have 2 constants defined, 2 integers for the pin button hours and the pin for the button minutes. And then we also have 2 states. So the state for the button hours and for the minute button. And they're both high, and as I showed you here in this note, well, it actually is a counterintuitive thing, because you think when I press the button it's high, and when I release the button it's low. But we're using this input pull-up here on line 62 here. I'll show you that in a minute, but then because of the pull-up, when there is no button pressed, the value is high, and when you press it becomes low. Then we have here on line 54 a time string with 9 positions, and that's basically used to store the string which we are going to show on the screen. And that is something I show you as well when we're going to the print screen, printing, drawing thingy. Here we define our screen for the U8G2 library with all the pins, and this is for my SSD 1306 display, but if you have a different display, on this website from Oli Kraus you can see exactly which one you need. Then we continue to the setup, where we set the button hours, which we've defined over here as pin number 3, and we enable the input pull-up. So that's the pull-up resistor, which is built in your Arduino, the same for the minutes. Then we use the U8G2 object and say set font. So we change the default font of the U8G2 library into Logisoso 28, and that font exactly fits into my screen. You can look at the U8G2 website for other fonts, but this one with the size of 28 fits perfectly when we're showing the time. Then we tell U8G2 that we're ready with the configuration and it can begin. In the loop, we check if the button has been pressed, so we store the current state of the button, of the hour button, in with the digital read, and we store it in the hour button state, button hour state, and we check if it's low. If it's low, we increase the number of hours. We do the same for the minutes. So if the button minute state is low, then we increase the minutes, and then we have several checks, because if we have more than 59 seconds, it means 1 minute has been passed. So on line 85 we reset the number of seconds and increase the minutes. The same we do for the hours, and the same we do for the minutes, and the same we do for the hours to see if a day has elapsed. The trick is that we first need to check the seconds, then the minutes, then the hours. If you do it the other way around, it doesn't work very well, because if we increase here the minutes, we need to check if we already go past the 59. And if you do the opposite, then you can have 60 seconds. Then we tell U8G2 to draw the first page. That's the way U8G2 works. And then you have a do while loop, and it repeats until there is no next page anymore. On line 107 we see something new. It's sprintf-p. Maybe you know sprintf. It's for formatted strings to print it. But the trick here with the underscore p is that we use program memory instead of RAM. RAM is a very sparse thing on the Arduino. So if we can use program memory, we reduce the load on the RAM. Well, what we do is, you see here PSTR, that means pointer to string. So what we do is the pointer of this string, this string, we are converting it to a pointer, and we store the formatted string into the variable time string. Well, this looks a little bit odd, but what it is that we say here 2 decimals, then we use the column, and then we use O to D. So here there is no 0, and here is 0 to D. That means that we're adding a leading 0. So it becomes 01, 02, 03, till we are at 10. And the same goes here for the seconds. So here we define how our string looks on the screen, and we store it into time string. Then we draw the string on the screen, so we print it on X position 0, Y position 45, and we're drawing the time string. Then we wait for a second and increase the seconds, and then the whole loop starts again. I'm now going to upload this code to my Arduino and show you what it looks like. I've uploaded the code to my Arduino, and as you can see, the clock is working. So let's adjust the hours by pressing the green button. That's not very easy to do. And if I press the minute button, it's also very hard to increase the minutes by 1. So what is causing this? Well, the reason for this is we're using delay. Delay doesn't wait for several milliseconds. Delay just pauses the whole processor for several milliseconds. So what's happening is that because we're pausing the whole processor for 1 second, it's very hard to detect if a button is pressed. You have to exactly press the button at the right moment in order to increase the hours or the minutes. That's not very useful for our clock. So we're going to solve this by using MILLIS. So let's have a look at the MILLIS code. Well, the begin is all the same, but here on line 58 there is a new variable. I created an unsigned long on which I store the current millis, so the amount of milliseconds elapsed since the Arduino was started. Then we have another variable, that's the elapsed time update millis. So basically what it does is it is to store the amount of time elapsed since the last time the screen was updated. Then we have an unsigned long last time update millis, and that's the timestamp when we did the last update of our screen. Then we have the constructor for the U8G2, which is the same as in the previous example. The setup is the same, but in the loop there's something new here. On line 83 we update the current millis variable with the current amount of millis elapsed. You can also take into account that millis itself also takes some time, and I looked it up and I found this website on line 82, and they showed me that it's 1.812 microseconds. So that's 0.001812 milliseconds. I'll leave it for now, but you can take it into account if you want to. Then we're going to calculate the amount of time elapsed since the last time update on the screen. So we take the current timestamp and subtract the last time we've updated our screen. Then we check if the buttons are pressed, we check if there are minutes and hours and seconds which we need to update. But for the millis, line 118 is interesting because there is no delay, so we need to check if there is enough time passed. So here we check if the elapsed time between two updates is more than 1000 milliseconds. If so, we update the seconds with, or we increase it with 1. And then we update the last time update millis with the current timestamp. But there's something which I'd like to explain to you. First, I thought that this would be suffice. So I just stored the current timestamp and I'm done. But what I noticed is that sometimes it takes more than 1000 milliseconds to update the screen. So what happens is that it's not updating the screen, it's more that it's not exactly on the millisecond cycling over the loop function. So if the loop execution takes exactly 100 milliseconds, then on 1000 is not larger than 1000, so then you have like 100 milliseconds in the next iteration, which makes it 1100, and then you can't do anything with that 100 milliseconds which you are too late. So let's say I have 1200 milliseconds in my elapsed time update millis, so this if statement is true. So I update the seconds, update it with the timestamp, so far so good. But I'm already missing 200 milliseconds because I updated timestamp with the current time. So that's 1200. But this was saving my trouble with the time drift because I now subtract the elapsed time update millis, so in this example 1200, minus the 1000, which is 200. So what happens is that the last update time will be the correct timestamp. So it only takes 800 milliseconds for the next second to update and saves us a lot of time drift. So you have to maybe reread this and just read the code a little bit slower for yourself to understand this. But basically what we do is we want to avoid time drift as much as possible because it will slow down or speed up the clock. This is all the same as we had in the previous example. So I'm now going to upload this code to my Arduino and show you what it looks like. So I've uploaded the MILLIS sketch and we're now going to see what happens if we press the button for the hours. So I can now easily adjust the hours and also the minutes are working. So now we're going one step further and we're going to add animation to our clock. The animation is quite simple. We basically draw a bar and this bar shows you the percentage of the seconds elapsed. So we need to add another variable and that's on here on line 65. It is the percentage of second elapsed. Now, that's 0. And the nice thing about this animation is that it needs to be updated as fast as possible, because if we wait for 1 full second, then every time a second has elapsed, so this value is 0, so you won't see any bar graph. So what I did, I added here 2 lines, sorry, no, I'm too fast. Here on line 130, we calculate the percentage of second elapsed. So we take the elapsed time update millis and divide it by 1000, 0.0. Why this 0.0? Well, then it becomes a floating point, and with the division you want to have a floating point as a result. So then we use this percentage, because the percentage it will be 1 for 100% and 0.5 for 50%. So we can use that to draw a bar. our screen is 182 pixels width, so we have 127 values, 0 to 127, so that's the complete width of the screen. So we first draw this box on line 137, which is on x0, y0. Then we have a width and the height. So the width is 127 minus 127 multiplied by our percentage. And the height of the bar is 2. The second bar is drawn at a y of 3. So the height was 2 from the first one, so there's 1 pixel line as a separator. And we do now the 127 times the percentage of seconds elapsed with a height of 2. So basically they are the opposite of each other. All the other lines are still the same, so I'm now going to show you how this animation looks on your Arduino. As you can see, our animation is working. You see the yellow bars on top moving from left to right. Also, the hour button is still working and the minute button works as well. There's one tiny thing what we like to fix. If I hold down, for example, the minute button, the screen is kind of flickering. The reason for this is that the update speed of the minutes depends on the speed of the Arduino. And we're going to solve this by a so-called debounce. And I'm going to show you how this works. So let's add some debounce to our buttons. And with debounce we are kind of controlling the way the button responds independent of the speed of the Arduino. So what we did was we defined a constant here, which is the debounce time. And 100 means that a button will be triggered at most every 100 milliseconds. So even if I press it twice during 100 milliseconds, the button will only be triggered once. So for every button, we need to define the elapsed button millis and the previous button millis. And we have that for the hours and here for the minutes. So what we check is we store in this variable how much time has elapsed since the last time I pressed the button. And this is the timestamp for the last time the button was pressed. And these are both unsigned long, since you might want to adjust the time while the clock has been running for many times, so then integer is definitely not enough. So then we're going to our code where we do the calculation. So this is still the same. We store the millis in the current millis variable. But here we calculate the elapsed time update, the button hour millis and the button minute millis. Because if the elapsed time is larger than the button debounce time, then we can check if the button has been pressed. If not, we don't have to check it because we can't trigger a button with 2 times within the debounce time. So then we read our button state, but we also update the previous button hours millis with the current timestamp, and the same goes for the minutes over here. Then we again check if the seconds is larger than 59, minutes, hours, all the same. Also here the percentage calculation is all the same, so nothing changes except that we now checked if the elapsed button millis is larger than the button debounce time. So I'm now going to upload this code to my Arduino and show you how this works. I've uploaded my debounce sketch to the Arduino, and when I hold my minute button, you see that the minutes will increase at a steady speed. This is because we added the debounce to our minute increase button. We're now going a step further by using interrupts. So let's have a look at interrupts. Maybe you've already followed one of my tutorials on buttons and interrupts, but I'm going to briefly introduce this to you again. So one of the things we want to do with interrupts is attach them to our pins. And that's something we do over here on line 84. So we have an interrupt, and that means that we don't have to check all the time if a button is pressed. What happens is that the interrupt, as the name says, will interrupt the program on a certain condition. So what we say here is we say falling, and that means that when we press the button, the interrupt will be triggered, and the interrupt is actually a function. So the function hours button pressed interrupt will be triggered if the pin button hours will be falling. You also have rising, that's when the button is released, and you have also change, but change isn't a thing we want, because if you press the button it will be triggered, and then when you release the button it will be triggered again. So you can never increase by 1, it will always be triggered twice. So then we have some weird flags over here, and that's because where I ran into was when I started my Arduino, it wasn't showing all zeros. What it was showing was 1 for the hours and 1 for the minutes. And it turned out that there were still some interrupt triggers left in the queue, and therefore on startup they were triggered. But the problem was that I don't want them to be triggered only when I press the button. And the trick was that you can clear the queue when using these commands here on line 95 and 96. Keep in mind that on the Arduino Uno there are only 2 pins which allow interrupts, and that's pin 2 and pin 3. So if you use, for example, pin 9 and 10, you can't use interrupts on these pins. If you have a different type of Arduino, for example the Mega has a lot more pins with interrupts. So keep that in mind, because otherwise it can take a while until you understand, you figure out that there is no interrupt on the pins you're using. So I split up my code a little bit, as you can see here, also with a function drawScreen on the end. And drawScreen does nothing else than all the draw methods we already had. But for us here, these are interesting. This is the hour button pressed interrupt, so it will be triggered when we press that button. And this is the same code as we had in the previous example, but now moved to a function. This is for the example, but normally you want to make your interrupt function as small as possible. So basically what you want is increase the hours and only increase the minutes, and all the checks you want outside of the function of your interrupt. But for this tutorial purpose I just put it over here so you better understand what's going on. So I'm now going to upload this code to the Arduino and show you how the button works with interrupts. So this is our running sketch on the Arduino with our interrupt code. As you can see, I can still change the hours and the minutes. One big difference with the last sketch is that I can, when I press and hold down the minutes button, it only increases once. This is because the interrupt is triggered, but you have to release the button until you can trigger it again. In our previous sketch, the triggering was read in the loop, so it checks continuously whether or not you have pressed the button. This concludes the first clock. We're now going to continue with the second clock, where we're going to use the mode and set buttons. In the second part, we're going to make a clock which is using a mode and set button. The advantage of this is that it's very versatile. You can add multiple modes without having to add another button. So how does this mode button works? Well, the clock starts by displaying the time, and when you press the button you can adjust the hours, then the minutes, you can reset the seconds, and if you press the mode button again, it starts by displaying the time. When you press the button again, it goes to hours, minutes, etc. The set button changes time depending on the mode you're in. So in the hours mode, you can change the hours, in the minutes mode you can change the minutes, and in the seconds mode you can reset the seconds. So this is what it looks like. You have an animation running, like in the previous clock. You have a time, you have a mode, you have a set button. But there's one different thing. You have a position marker. This position marker indicates what you are changing. So here you are changing the hours, the minutes, or the seconds. In the next steps, we're going to implement first a mode set clock without interrupts, and secondly, we're going to create a clock with interrupts. I'm going to show you how we can do this. So we're going to create a clock which has a mode button and a set button. The structure is basically the same as our previous clock, but there are some differences. For example, I've renamed all the hour buttons to the mode button and all the minutes buttons to the set button. So we also have a new debounce here. I've separated the mode and the set button with different debounce times. And here you also see some constants defining the modes. So I have a mode to show the time, a mode to set the seconds, the minutes, and the hours. So in the background I'm using just numbers for this, but it's a lot easier to read the code when there is this name instead of saying mode is 0. You have no clue what 0 is. So we need a variable to store the current mode, and that's here on line 78. I don't use an int because a byte is sufficient. We only have 4 numbers to store: 0, 1, 2, and 3. So the setup remains the same. And here on line 100, we read the state of the pin button mode and check if this one is low, and then we activate the button mode handler function. And the same goes for the set button. Then we call the set handler. We check the time. That's another function, and the check time is here just to check if there's a minute elapsed, an hour elapsed, or a day elapsed. And here is something new, because here we check if the current mode is show time, and if so, then we increase the seconds. And increase seconds is here at the bottom. We check if the time has elapsed, and then we update the previous time, MILLIS, etc. I've told this in the previous example. So then we, if it's not in the showtime mode, so basically we're setting a value for the hours, the minutes, or the seconds, then it just updates the previous time update MILLIS with the current MILLIS, and it draws the screen. So let's have a look at these handlers. Well, for the mode it's fairly simple. What we do, if the debounce time has elapsed, of course, we increment the current mode. So if you are in mode 0, which is showing the time, you do ++, which is the same as +1. So then we are having the set hours, etc. But there is no fourth mode. The highest mode you can have is mode number 3. So if we reach the 4, because the previous was 3, so now with current mode it's 4, then we reset it back to 0. And in that way you can press the mode button all the time and just iterate over the 4 modes we're having. The set button does something more, because the set button works depending on the mode you're in. So what we do is we check if the current mode is set seconds, and if so, we reset the seconds. But if the current mode is minutes, then we increase the minutes, and if the current mode is hours, we increase the hours. If you want to set an alarm, for example, and you create a custom mode for that, then you can add another if, checking if the mode is set alarm or stopwatch or whatever. So let's have a look at the draw screen function here, because I've changed something as well. If the current mode is not show time, that means we're setting the hours, the minutes, or the seconds. So what we do, we need to draw a triangle. And the triangle indicates if we're setting the hours, minutes, or seconds. So if you're setting, for example, the minutes, there's a tiny triangle on top of the minute number, so you know you're changing that value. So you see a lot of numbers here, and I'm going to explain to you what they mean. So first here, this is the first number, this is the X position, and the X position is the current mode -1. So if we're in mode number 1, it's 0, and in mode number 3, it's 2. And we're doing this because I've split the screen in 3 parts. So I want, depending on the mode, draw the triangle on a third of the screen. So here I multiply the current mode minus 1 times 43. So if I'm in mode 1, minus 1 is 0, times 43 plus 5 is 5. And the thing is that this 43 is a third of 128. And I can't use float numbers, so I made it this way. And 5 is some kind of margin. I don't want the triangles to exactly be 1/3 of the screen. I want it 1/3 of the screen minus 5 pixels on both sides. The Y position is 0. So that's our first most left point of the triangle. But what we then do is we take the current mode, and here we did minus 1, here we don't, multiplied by 43 minus 5. So that's our top right point of the triangle, and it's on Y position 0. So now actually we have drawn, if we draw a line between those 2 points, we draw a horizontal line. So if you look a little bit further, then you see here the current mode minus 1 times 43. So this is the same as over here. But I add 21. And why do I add 21? Because if we divide 43 divided by 2, then you get a floating point number, and that's not what we want. So I create an integer. And that's the center between our first 2 points. But instead of using a y of 0, I use a y of 5. So now we have a triangle with 2 points, 1 point in the center, which is 5 pixels offset from the other 2. What you can do is fiddle around with these numbers to see how this draw triangle exactly works, because now I'm telling you it in the code and it's very theoretical, but if you change the numbers you'll see for yourself what happens. That's basically the whole code for this clock. So I'm going to upload this to my Arduino and I show you what it looks like. So our mode and set code is running on the Arduino. With the mode button I can change between hours, minutes and seconds. So let's start by adjusting the hours. So I select hours and I can increase it with my set button. The same goes for the minutes, and I can also reset the seconds. When I press the button, the mode button again, it goes back to time and you see the seconds are increasing, so our clock is running again. I'm now going to show you how to implement this clock with using interrupts, and we're even going to use a timeout. So we're going one step further and we're going to use the interrupts and the timeouts. It's not very hard because we already made the first clock with an interrupt. So what changed is that here we have now interrupt clear flags, as you can see. So we clear the queue again, as in the previous example, and we attach 2 interrupts here. And when the mode is pressed, we call the function mode button pressed interrupt, and for the set button pressed interrupt. So if we have a look at the code of these interrupt functions, you see here for the mode pressed interrupt, we say button mode pressed is true. And here you see button set press is true. I like to keep these as light as possible. And with that I mean as dumb as possible. So this one is only setting a variable to true, and that's basically it. You want to keep your interrupt functions as clean as possible. But there's this special thing here. Button mode press is a special variable. If we scroll a little bit up here, you see button mode press, which is a boolean, but here you see a new word, volatile. And volatile means that you can use it in the loop function and in the interrupts. If I didn't add volatile to this variable, what could happen is that a function in the loop is actually modifying button mode pressed, and at the same time I press the button which raises an interrupt, and then you can have some kind of what they call race conditions and stuff, and that's solved with volatile. If you want to know more about volatile, Google it, There's a lot of information out there. So I kept it quite dumb, because here I check if the button mode press is true, and if so, I'm calling the mode button handler. So in my previous clock I had all this code inside the interrupt, which isn't the best way to do so, but was easy for the tutorial. But now we're going to write more clean code, so I moved it into these functions. And as you can see, this is exactly the same code as we had before, except for this line, because I set button mode pressed back to false. And the same goes with the set button. Here, button set pressed goes back to false. So there's one more thing, and that is the timeout. So with the timeout, we're going to show the time if we don't do something for quite some time. And that time is defined over here on line 53. Is the mode set timeout. So basically we wait 500 milliseconds, so 5 seconds. And if we don't do anything for 5 seconds while setting the hours, the minutes or the seconds, it will return to displaying the time. So how does this work? Well, we already kept for the debounce the time since, the timestamp since we pressed the button for the last time. So what I do here, it's actually very easy on line 125. Here we check in two parts if the elapsed button mode millis is larger than this 5 seconds, than this 5,000. And the same here for the set button. So if we haven't pressed the mode button and the set button for the period of time defined in mode set timeout, then the current mode becomes mode show time. So it shows the time. You can fiddle around with this as well, because you can also say, well, you have to wait for 10 seconds and then I want to show setting the hours. You can change it to whatever you want. But that's how this works. So actually it's very easy, because we already kept the time when we press the button. So you just have to see if it's larger than our timeout. So that is basically the code. I'm now going to send this to my Arduino and show you how the timeout looks when it's running on Arduino. So our code is running again on the Arduino and nothing has changed. You can still select the different modes, so I can adjust the hours, the minutes, reset the seconds. But there's one big difference. If I'm going to edit the time and wait for 5 seconds, then you'll see it resumes showing the time automatically. And this is exactly as we configured in our code. We defined that if a certain amount of milliseconds elapse, it will go back to its default mode, which is showing the time. This concludes the tutorial on this digital clock. You have learned why you shouldn't use delay and how you can use MILLIS to solve the problems with delay, how to add your own animation, how to use debounce on the buttons, how to use interrupts, and how you can use the several modes, so you only need to use 2 buttons. You can easily extend this clock by adding new modes, for example for alarm or stopwatch. You can also use a real-time clock to make the clock more accurate. And there are many things that you can think of, and I encourage you to experiment with this clock. If you have any questions, feel free to drop them in the comments. And in the description of this video you'll find a link to the course material, the circuit schema, and a shopping list with all the parts used in this tutorial. I see you in the next video.